Okay, it's 10 a.m. so we start the lecture. So good morning. So I think I see a lot of you in another class. I have seen the Bradley in the last Stat 5030. Yeah, Kenny is in the last year in Stat 5030 and many others. Yeah. Okay, so today's contents. So at first I cover syllabus, and after that, since this is the first class, I would like you to introduce yourself one by one. So your name and your major, and maybe the reason you are taking this course. I mean, why you are interested in this course, and whatever you want. Then after that, we do some breakout sessions to chat with other students. And after that, we start chapter 1, and the slides are available on the website. Those slides are incomplete slides, and I will write on those slides on iPad during the lecture. So you can fill out the line or you can take memo. Okay, so we start. I start explaining the syllabus. Sorry, maybe I share the screen. Yeah. Oh, and this is the Mass 5740, the theory of interest class. Yeah, so I worked for the central bank
It should
for
be
4.5.
Math 5740 22W.
Yeah, so 5740, so 22. So I don't have a traditional career as a college professor. So I worked for the central bank for 4.5 years, and I did some economic analysis and the financial analysis. So that's the reason I'm teaching this course. So I took actuarial exam in the United States, and also I passed a couple of exams in the Actuarial Society of Japan. And I'm a statistician. I have a PhD in statistics, but this course is not related to statistics. So this is more deterministic arguments. So all class materials are not, non-statistical. Yeah, so my name is Kazuhiko Shinki. You can call me Kaz. And email address that I'm using the two addresses. Sorry. But the both addresses are both. So if you send just one of these emails, then I will receive it in the same address. And we use the Canvas as the course website. Lecture is Monday, Wednesday, 10 to 11:15. So in the first 3 weeks, we have classes online. And after that, it depends on how the Wayne State University decides. And office hours, the Monday, Wednesday, Friday after the lecture, from 11:45, maybe 30 minutes after the lecture, and Zoom only. So last semester, I have office hours in class and also in Zoom, but actually no students appear in the physical office hours. So this time, the Zoom only. If these times do not work for you, then you can just email me for an appointment. Prerequisite, the Math 2020. So calculus 2. So yeah. So some contents are just algebra, but we need some calculus. So one reason is that sometimes the interest accumulates continuously. Interest rate changes daily or even in a half day. So that's the reason that we use the continuous argument. And also, if you see the financial market market, the bond price changes, and that change is better explained by more continuous argument. So that's why that we need the calculus, but not beyond that. Textbook, the study manual for the actuarial exam, the FM, Financial Mathematics, or exam 2 for, I don't know. So we have the 2 actuarial societies, so the SOA and the CAS, and those have the different names, but actually those are the same exam. And this textbook is the 15th edition now. So I got 15th edition. And I also had the 11th and the 13th edition. And as long as the edition is 13 or later, that's fine. Before that, the exam curriculum was different. So we have slightly different book, but just to have the one of them is fine. I think it's not really cheap. They're $170. Yeah, but certainly it's worthwhile to invest if you're interested in actuarial mathematics. So, the return of this course is much higher than usual cost if you are, considering an actuarial career. And actually, the first 100 pages of the textbook is in Canvas, so you can see how it looks like. And this is very easy to read textbook, so for self-study, it's very good. And all exercise and homework questions will be given online, so you don't need it for that purpose. Different versions have slightly different questions. Yeah, and calculator. So this is absolutely necessary to take this course. Texas Instruments, the BA2 Plus or BA2 Plus Professional Edition. Yeah, if you see Amazon, BA2 Plus costs about maybe $33, and the BA2 Plus Professional maybe $47. And those are basically the same calculator. The Professional edition have slightly more functions. So if you're entirely, not good at mathematics, then maybe Professional edition occasionally helps, but you are probably math major, so it doesn't really matter. I have Professional edition, maybe, but only $13–14 difference. Yep. So the reason that we need this calculator is that the calculator has some functions which is not included in the traditional calculator. For example, it's of course easy to calculate how much interest accumulates for 3 years if the interest rate is 3%, like the 1.03 to the third power. That can be done by any calculator. But how about, okay, so we have doubled our deposit in 10 years. What's the annual interest? We have to solve some equation, right? So if that equation becomes complicated, that we have to solve like the 5th degree, equation or something. So that cannot be done, analytically. So that function is included in financial calculator. So that's why we need this calculator. And lecture in Zoom, you are here, so already this link. And the recorded lectures are in YouTube. So after the lecture, I will upload the lecture. And also the last year, the class is entirely online, asynchronous. So you can find the videos corresponding to our lecture. Office hours, we have different link. And the learning outcomes, so our objective is to obtain applicable knowledge of interest and fixed income products, such as annuities, the bonds, and loans. and get an image of actuarial mathematics. Maybe you are at this point not entirely sure if you are interested in, but at least you can get some image about what is done in actuarial mathematics. And this is also important course, and you may be interested in the actuarial exam, and but the actuarial exam is very, the intensive exam. So if you are taking this exam, you need more practice. So I will cover probably the 80% of the contents, but to pass the exam, you need more practice. So the actuarial exam that typically requires the 300 hours to pass the exam. Pass an exam. So we have several components, but for each component, 300 hours are needed for typical students. So if you're good at math, maybe you can shorten that time. But okay, so think about how much time that you will spend on this class. So your attendance to the classes, that is about 35 hours for the entire semester. And you do homework and prepare for the exam, probably you have to spend the 19 hours more. But that is in total 125 hours. So you need additional 175 hours to pass the exam. So not finishing this course does not mean you can pass the exam. So many students, they passed the exam after taking this class, but probably they prepared more. And the daily quizzes, we have some online quizzes. So that are basic questions. So if you understand the lecture materials, then you should be able to answer within maybe 10 minutes. It depends on the question. So some questions are really easy. There's some questions that you need more calculation. And homework and weekly quizzes. Homework will be assigned every week on Wednesday after lecture. Then the quiz is the following Monday, on the following Monday. So, and these quizzes are a little more difficult than daily quizzes. It's still maybe slightly easier than actuarial exam questions. And for these quizzes, I would like to see your solutions. So not just the answer, but I would like to see how you solved the question. And also you can possibly get partial credits even if the final answer isn't correct. And basically, I'm planning to have quizzes in the last 15 minutes of the Monday classes. So the Monday class. So at 11 a.m. we start quizzes, and every Monday, and you have to solve it, and you can upload your solutions to the Canvas. And my suggestion is to use the CAM scanner. So this is the free app in Android and iOS. And you can only need the free version of the CAM scanner. So you can take the picture of it, and the CAM scanner transform it into PDF, and it adjusts the angle and so on. Or you can just use the scanner, flatbed scanner, or anything else, as long as I can read it clearly. Yeah, and the solutions to the homework is given at the same time as the homework is given. So you can do self-study, and I will check the understanding by quizzes. So homework will not be collected. So exams are in a similar format as the weekly quizzes. So I upload the exam by 10 a.m. on the exam date, and you have to submit within 75, maybe 80 minutes. And grading, the daily quiz is 18%, weekly quiz is 18, midterm 1, 18, midterm 2, 18, final exam 28. Final exam is longer than midterm exams, so we have higher weight. It's not entirely cumulative exam, final exam, but it includes some materials from the past exams. I will specify what's included in the final exam. Yeah, and any cheating or plagiarism may make your grade F, and to get an A, your score has to be 80% or more on average. And the schedule for midterm exams are here, February 7th and the March 21st. And the final exam, May 2nd from 8 a.m. So it's really early. So be careful that you get up early enough. Yeah, and if you have any time conflict, just let me know. And quizzes that I don't allow any make up quizzes, but the exams, suddenly, if you have any time conflicts with other schedule, then just let me know beforehand, so we can do it a little early, maybe, or on the same day at a later time or something like that. And the writing intensive courses. So how many of you are in actuarial mathematics major? Hello. Does any of you major in actuarial mathematics?
Yeah, I just majored in mathematics, not actuarial.
Okay, I see. Then that's fine. Bradley, maybe. Oh, okay. So several ones, and I think that you have the if you are okay. So at least 3 people. If you major in actuarial mathematics, BA in actuarial mathematics, then I think that you are required to register for Mass 5993 in conjunction with this course. I don't know, the computer system is complicated, but have you registered Mass 5993? Yes, yes. Okay, great. Then I will give some very small data analysis project, so you can solve it and submit by Monday, April 4th. So this is part of the materials not covered in this lecture, but included in the actuarial exam. So certainly it's useful for you. And also the data analysis is not included in the course material, but it's included in Mass 5993. So maybe it's also useful to see how data analysis works in actuarial mathematics. And I haven't posted the homework, but I will post by maybe the beginning of March. Okay, and the SOA exam, FM, schedule in 2022. So if you're considering to take exam, then we have basically the exam, the actuarial exam FM, 6 times a year. Basically, these are computer-based exams, except for the very exceptional cases. So the deadlines and the exam dates are here. So probably if you have finished the course, maybe the June exam or August exam, these are probably the optimal for you to take, maybe. And certainly it's useful if you look for the internship or employment at the insurance companies or pension companies or consulting companies. But just to double check the dates before you register for it. So I checked it by myself, but the 99% correct, I believe, but still I may have made a mistake. Yeah. Okay, so that's it. Do you have any questions? Okay, maybe I launch some polls or something. What's your major? Actuarial math already for people, but statistics. Oh, okay. So general math. Others. 8. Okay, so 9, 1, 4, 4, 5, 10. Okay, so that's the actuarial math, the 5 people, and other math majors, the 4, and others. Who answered others from other department or graduate? Econ. Okay, I see. Yeah, that makes sense. Yep. Okay, so now that I would like you to introduce yourself, your name, your major, and why you got interested in the course. Okay, so maybe how to okay, so maybe ABC order in the full name. So Aaron.
Yes, hello, Professor. I'm a econ major, a stats minor. I'm a senior as well, so this is my last semester, and I was interested in this because, as you said, the interest rates, the economic analysis that you can do with it, I feel like it'll really help me in my future. So
I see. So you did some analysis on the interest rate the last semester, right? Mm-hmm. Yeah. Mm-hmm. Okay, so Anna, Laura.
Hi, my name's Anna. I'm an actuarial mathematics major and a dance major. I'm really interested in this course just because actuarial mathematics is very interesting to me. It's like playing magic with numbers. And I'm a junior.
I see. Thank you. I have seen the first student who major both dance and the mathematics, but yeah, that's great. Bradley.
Hello, I'm Bradley. I'm a actuarial mathematics major, and I'm a senior, so this is also my last semester, and I just really enjoy this type of math. So
okay,
that's why
great.
But it is part of the requirements, so that's why I'm
here. Yeah, sure. Yeah. Donovan.
Hi, I'm Donovan. I'm a mathematical economics major and a stats minor.
I see.
I took this class because I had to pick a 5,000 level math course and it sounded interesting. Mm-hmm. And I just have 3 classes to do after this semester. And I have to figure out how I want to pace that out.
Mm-hmm. I see. Mm-hmm. Yeah, math econ. Yeah, that also makes sense. So, Essam.
Hi, my name is Isam. I'm a senior. I took this class because it's part of my requirement in majoring in actuarial mathematics. And, I'm looking for a career in actuarial math. So learning about concepts relating to interest, bonds, and things like that, I think would be useful for me.
I see. Oh, and by the way, so I recommend all of you to turn on videos as long as it's available. Yeah. So yeah. So I learned that if you are watched by others, then you can concentrate on the lecture more. So now I think it's the more. I haven't started lecture yet, but yeah. So certainly I strongly recommend to turn on videos. Okay, so Garrett.
Hi, my name is Garrett Clay. I'm a junior. My major is actuarial mathematics, and I was interested in this course because, one, it's required, but eventually, if you want a career as an actuary, you need to take exam FM. So hopefully I can do that this summer.
Mhm. Oh, okay, so that's great. Yeah, summer is a good time to do. So yeah, the 80% of materials are covered in the lecture, but then maybe you spend some more time to take the exam. So yeah, so that's great. And yeah, by the way, the FM exam is the officially the second exam. Of course, you can take the FM exam first. So that means that usually the exam takers have already passed the first exam. So that means, the most, test takers are, good at mathematics. So that means a little bit more, the exam is a little bit more competitive than the exam P. Also, mathematically, it's easier. The FM is easier than P. So just think about it. So FM may be the first exam you can take, or P exam you can take. And certainly if you're taking this course, FM exam is good exam to take, but just I would like to give that tip. And we have the two, Garrett, maybe the same, I don't know, Garrett?
No, there's two of us.
Two of you, okay.
I'm Garrett, I'm a junior. My major is actuarial mathematics, and I'm taking this class because it's required, but it also seems pretty interesting, so I'm excited.
Okay, thank you. That's great. So Garrett Clay and Garrett Coletti, I see. And Hunter?
Hi, my name's Hunter. I am a math major and a senior, and I wanted to take this class to just learn more about actuarial math.
Mm-hmm. I see. You have taken the stat 50/30, right?
Yeah, that was last semester.
Okay, yeah, I see. Sorry. Kenneth?
Hello.
Hi.
Something's wrong with my video, so I'm unable to show it. But my name is Kenneth Graham, and my major is in mathematics. And I'm taking this course. This is an extra course. I decided to take it to learn about the business side of math. I haven't really looked into much of the business world, but I would like to look and see how to do through what I know about math and connect that to business opportunities.
I see. Yeah, certainly. Yeah, it has the course has a business flavor, and the finance, the 3290 also has similar contents to this theory of interest. The finance 3290 is more financial course and less mathematical course, but some students find it useful to take both courses. The course is required by actuarial math major. And Sydney?
Hi, I'm Sydney. My major is actuarial mathematics with a minor in stats. Obviously, I need this class to graduate, but I'm hoping it'll help me with the actuary exams.
I see. Yeah. Okay. So thank you. And any others? Sorry, there may be some students just come in. Maybe one student. Yeah. Okay. So now I will make maybe the 3 breakout sessions, so that you can talk 3 minutes about what courses are you taking, what other courses are you taking, or what have you done in the winter break, or what you are going to do this year or this semester, or whatever you want. So I will split this into several sessions. Sorry, I have trouble to make breakout sessions, breakout rooms, assign automatically, maybe 3 rooms. Yeah. 3 minutes. Yep. 1, 2, 3. Yep. So you can talk for 3 minutes, and I will change the I will shuffle the room after 3 minutes. Okay, so okay, great. Okay, so I will set up the breakup room again. Okay, so I will shuffle all students. And 3 minutes again. Hopefully we have different group this time. Okay, 3 minutes again. Okay, so I hope you enjoyed some chat with your classmates. So now I'm starting the lecture. Okay, so everyone can hear me?
Yes.
Okay, great. Okay, so the lecture note, actually I added a couple of slides in the lecture note. So lecture notes are for the first 3 classes. This is for chapter 1. And at first, the actuarial exam. So this course covers the materials for actuarial exam FM2. So that is the second exam in actuarial exam. So actuarial exam, the preliminary exam have 6 components, maybe the 5 for the CAS, the casualty, the association of, casualty actuarial society, I don't know. And SOA, that we have 6 exams. Then the second step is the VEE, the validation by educational experience, or the some more standardized tests. Then after that, the advanced exams, that is more specific for either pension or health insurance or casualty insurance or more finance. Yeah, and the key for the actuarial exam FM. So what's the key? I have some maybe the 6 items to mention. So first one is certainly the notion of the fixed income products. So fixed income products are, for example, mortgages and the bonds and some other type of cash flow and so on. And for example, when interest goes up, the bond price goes down or goes up. Does anyone know the answer? When interest rate goes, yeah.
Oh, I was gonna say, can you repeat it again?
Yeah, sure. When interest rate goes up, does the bond price go down or go up?
It also goes up.
Actually goes down. So you can think about this way. So suppose that the interest rate is 3% and you bought a bond. After one day, the interest goes up to 4%. Then you feel that I shouldn't buy the bond yesterday, because if you buy today, then interest rate is 4%, right? So basically you made a loss. So that's why the bond price goes down. So this kind of the notion is covered in the lecture. And the notion of also the notation of the fixed income products is covered in this course. So for example, the mortgage, usually many of the mortgages have the 360 months period. So often the amount you can borrow with 360 months loan is written as the A right angle 360. And sometimes even we have notation such as the 30-year loan with 12 payments per year or something like that. And sometimes we specify interest rates such as 0.05 or so on. So sometimes I feel that notation of fixed income products in actuarial mathematics is unnecessarily complicated, but this is the way the actuaries do for the long time. Probably the reason is that in old days they don't have computers, so they have to prepare all notation to calculate for example, the price for a 30-year mortgage. And the next one is terminologies. So everything related to finance should be very accurate. For example, the 30-year loan, when the first payment starts. So we have many terminologies such as, annuity due or annuity immediate, depending on when the first payment starts. So terminologies are also important. And also the use of calculator. So to maximize the benefit of notation of the fixed income products, the use of calculator is also a key part, especially to take the exam. And I think that this is the most important part. And the next point is the translating sentences to mathematical expressions. So mathematical expressions. So, okay, so this course only uses calculus and some algebra. So why this course is useful. So the reason is that you have to translate sentences to mathematical expressions to apply mathematical knowledge to real financial problems. So next page, we have a sample, the weekly quiz. So you deposit $800 today in a bank account A with 5% annual effective interest, then interest rate payments will be deposited into another bank account B earning 10% effective interest, and the interest earned in the account B will be invested in another bank account C, and so on. Okay, so you can see that the sentences are complicated, and the translating the sentences into mathematical expressions is the key part in this exam. And I believe that the people who make the actuarial exam, sometimes they make the sentences complicated on purpose. So this is because they want the applicants, they want to hire the actuaries who can translate the sentences to mathematical expressions. So this is probably the key part in the exam. And finally, okay, so in terms of the exam prep, the speed is important. And especially last year, students suffer from this because online environment, you can spend a lot of time to answer quizzes. So last year, there's no time limit for quizzes. So students, make, the beautiful, solutions, and they got the, the full credits on all quizzes or something. But sometimes their solutions indicate that they spent too much time. So in actuarial exam, you have I think the 3 hours, and you have the 30 questions. So 30 questions and 3 hours. That means that you have to, you can only spend
6 minutes.
6 minutes, right? So it's very short time. So that you have to, very efficiently calculate everything. So those 6 points are the key points of the actuarial exam FM2, and also important for this course. So this is the college class. So I focus more on notation and notion. But also, this part, the translating sentences into mathematical expressions, are the key part for actuarial exam. Yeah. Do you have any questions, comments? Okay, so
I forgot to mention that at the end of this term, I'm going to be graduating with a bachelor's in my major mathematics and sciences.
Sorry, can you say again?
I forgot to mention by the end of this term, when this term is over, I'm going to be graduating with a bachelor's of sciences in my major of mathematics.
Okay, thank you. Yeah. Yeah, certainly if you're interested in, even if you are in math major, like pure math major, it should be useful. So some students mentioned that, that they enjoyed the class because, I can apply the mathematical formulas to real, financial problems. Okay, so first introduction, so notion of interest. Okay, so an example. So if $100 today will become $103 a year later, we say the interest rate is 3%. Okay, so this is natural. And questions. The first question, what is the value after 2 years from now? So $100 becomes 103 after a year. So one way to calculate interest is, okay, so $3 per year you can get. So $106 after 2 years. So this is the so-called simple interest rate, often used to calculate interest in your bank account. And another way to calculate the interest, this is maybe little more convincing. So 100 times 1.03 square. So 106.09, so $106.09. So this is called the compounded interest. Okay, so we cannot say which is correct, but at least you have to specify how interest accumulates. And similar question, what is the value a half a year from now? So 1 year, $103. So if we use simple interest, one possible answer is 101.5. So $3 for 1 year, $3 interest for 1 year. So $1.50 for a half a year. So this is simple interest rate. But if we use the compound interest, then we may think this interest as 100 times 1.03 to the half power. So this is compounded interest. But this is actually not consistent with compounded interest in the question 1. In the question 1, it compounds once a year, but the question 2, it compounds every half year. So we have to specify how many times it compounds a year. So you can see you have to be very specific to calculate the interest earned on some amount. And the typical question in this course is like this. So to receive $365 once a year for 10 years, starting 1 year from now, then how much should we have today if annual interest rate is 3%? I don't answer this question immediately, but okay, so the notion is we have the timeline of 10 years, so 1, 2, 3, up to 10. Then every year that you receive the $365 starting 1 year from now. So how much we should have? You receive $3,650. So okay, so interest rate is 3%. So if you have $3,650 today, then of course you can get these amounts, but you need less money because the interest accumulates. So I don't know, this may be $3,000. I don't know, but we prepare the formula that we calculate this. And another one, so to receive $1 a day for 10 years, starting from tomorrow, sorry, some redundant one, how much should we have today? So basically it's similar amount to the first one, but we don't receive $365 as a kind of a lump sum payment, but we get $1 each day, and we start receiving money, tomorrow. So that means that we receive some money earlier than the question 3. So probably amount is a little larger than 3,000. If this is 3,000, and we cover this kind of calculation in this course. And another one, to receive $360 a year forever, how much should we have today? So you have the right to receive $365 forever. Maybe you will die, but maybe your I don't know, yeah, your son or your daughter or even grandchildren will receive money. So you have the right to receive money forever. So such product is possible. The value is finite or infinite. How many people think it's infinite and how many people think it's finite? Maybe I launch some survey polls, share. Sorry, I'm not sure about how to make it. Something is wrong here. Wait, okay, so maybe you can answer. So how many of you think that it's the value is finite for question 5?
I do.
How many people think infinite? Maybe it's better to make a poll, but I don't know why this is. Okay, so finite or infinite. Okay, so question 5 launch. How many of you think the answer to the question 5 is finite and infinite? Finite 4, finite 6. Okay, how many people are there? 10? Okay, so 8 people finite and 2 people infinite. Okay, so any of you who answered finite, why you think this is finite?
I think it's finite because the way the question is worded, I'm thinking that's similar to compound interest. Compound interest where I have to deal with the exponential function. I think that's going to give a finite value. I've worked with it in the
Right. So your answer is exact. Yes. Yeah. Yes, that's true. So think about the $360. The current value of $365. Sorry, the current value of $365 paid 100 years later. So that is the 365 times 1.03 to the power negative 100, right? So the value, decreases exponentially with time. So that means even we take summation, that is finite. So this is finite. So at least it's not 100% clear. So actually the 2 of the 10 students thought the value is infinite. So it's not clear. Sometimes the value becomes infinite if for example, payment increases over time, then the value can be infinite. So we cover this kind of thing. So these are the materials we cover in the lecture. Of course, we cover more. We use calculus and more, but just this gives ideas on what kind of things that we do in class. Okay, so now we only have this 18 minutes, but we start the textbook. So first, basic concepts. Okay. And first, definition. An accumulation function, usually we use AT, A of t, is the value of an asset at time t. And for standardization purpose, that we define A0 as 1. So this means that it's defined by 1. Okay, so basically, interest accumulates. So usually this becomes exponential function, but also interest changes over time. So if this is t, maybe 1 year, 2 years, 3 years, and so on, then okay, so y is the value of the asset, and that we standardize at time 0, the value is 1, then like this. So this is the y's A of t. So this explains that this $1 becomes, for example, maybe $1.75 3 years later. And this gives the answer for how much interest it accumulates. For simple interest, maybe this increase is linear, and for compound interest, this increase is exponential, but interest changes over time sometimes. So in general, AT is an increasing function starting at 1. I mean 0, 1. Yeah, and another thing, so this is similar, but the amount function, capital A of t, is the same as the AT, but lowercase a of t, but the A of 0 does not have to be 1. So that means for some constant k, the capital A of t is equal to k times lowercase a of t. So lowercase a of t is standardized, and the capital A of t is actually the amount you own. For example, if you deposit $100 in a bank account, then capital A of 0 is 100, and capital A of t means the amount of money in the bank account at time t. And if the terminology, so if the start date and end dates are clear, then we say capital A of 0 as present value. And capital A of v is defined as capital A of t. Usually the end point, maybe we use the capital letter t. Start date is 0, end date capital T. Then capital A of t, capital A of capital T is called accumulated value. For example, if it's clear that you deposit money today and withdraw all money 10 years from now, then we just close the bank account. Then A of 0, the value is the present value is the current bank account balance, and accumulated value is the amount 10 years later. Any questions? Okay, so the next one, so the definition. So we have to define the interest rate. We have simple or compound or so on. And we define at first the effective interest rate, effective rate of interest. In the teeth year, we have first year, second year. Okay, so we think about just an integer and a teeth year. And that is denoted by I sub t. And this is defined by A of t minus A of t minus 1 divided by A of t. A of t minus 1, sorry. So the denominator is the amount at t minus 1, and the numerator is the increase. So that is usual way to calculate interest rate. And or you can also say capital A of t minus capital A of t minus 1 over the capital A of t minus 1. Because just capital A is k times larger always. So that means if, for example, the I sub t, maybe I sub 3 is equal to 0.08, then that means the AT or capital A of t, the increase is 8% in the third year. So that is I sub t. And maybe another example. So suppose A sub t is equal to the 1.1 to the tth power. What is I1? What is I2? Then this is exponential function. So you can see that always it increases by 10%. And actually you can verify it. You can say that the I1 is equal to A of 1 minus A of 0 over A of 0. So at time 0, amount is 1.1 to the 0th power, 1.1 to the 1, 1.1 to the 0. Then this is 0.1 over 1. So this is 0.1. So 10%. And I sub 2, the effective interest for the second year, A sub 2, A of 2 minus A of 1 over A of 1. So that is 1 plus 1 square minus 1 plus 1 over 1 plus 1, I mean, to the first power. So this is what? This is 1.21 minus 1.1 over 1.1. So this is 0.11 over 1.1. So this is again 10%. So in this case, the I is constant. So if I sub t is constant, then we write this as I. So often interest rate is fixed. Effective interest is fixed as a constant, and we say this as I. So we don't have complex numbers in this class. So I is always interest rate. Any questions? Okay, so maybe slightly more complicated examples. Example 2. So suppose that I1 is equal to the 0.01, but I2 is equal to 0.02, and I3 is equal to 0.03. So the first year, 1% interest, second year, 2%, and third year, the 3%. So that is typical, the path of interest rate. So do you know, so currently the interest rate is near 0 in the United States. Do you know what's the expectation for the interest 1 year later? Anyone? Maybe if we are in econ major or actuarial math major.
I know they've begun tapering with their quantitative easing.
Yeah.
But I'm not sure what their goal is for the interest rate. I assume they're going to keep it probably low.
Right. So the tapering, the Federal Reserve's plan is that they are the tapering. So they are quitting to buy more bonds in the financial markets until March. Then after that, they may increase interest rate, and possibly we have the 3 interest hikes of 0.25% each. So maybe the interest rate at the end of the year is 0.75%. That is the market's expectation. So typically, increase of 1% per year, that is the typical path of interest rate. Sometimes 2%, that is the pretty steep. Okay, so what is accumulated value at time 3? So interest rate is 1% for the first year, 2% for the second year, 3% for the third year. What's the accumulated value after a year? So we want to get A3. A3 is certainly the A. Maybe you can say that maybe A1 times the A2 over A1 times A3 over A2, 1, 1, 2, 1, 3, right? 1, 2, 3. Yeah. And A1 is 1. That's true. And A2 over A1. Sorry, maybe one more time. It's just the A0 over A1 is A0, sorry. 1, yeah. We transformed in this way because this is exactly the definition of I1. Okay, and we can do the same thing. So 1 plus A2 minus A1 over A1, A of 1, and times 1 plus the A3 minus A2 over A2. Then this is, the 1 plus I2 and 1 plus I3. So this total, and A naught, A of 0 is equal to 1 by definition. So this is the 1 times 1 plus I1, 1 plus, sorry, the 1 plus I2 times 1 plus I3. So this is 1 times the 1.01, 1.02 times 1.03. So this is about 1.06, 1.0611. So we get the 6.11 cents on $1. So in general, so A of t, if t is an integer, this is given by 1 plus I1 times 1 plus I2 times up to 1 plus I sub t, or you can say this is the product j is equal to 1 to t, 1 plus I sub j. Yeah, I think it's good to write at least once to memorize, to understand and memorize the formula. Yeah, so this is very discrete argument, and you can see how interest rate works. Any questions, comments? Okay, so next one, we now define the simple interest and the compound interest. So definition, so at first the simple interest of I per year, that means that the A sub t is equal to 1 plus I times t. Here the t is the number of years. So example, what is the effective rate of interest in the 5th year for 5% simple interest rate per year? Okay, so simple interest rate, 5%. So $100 becomes 105 after a year, then 110, 115, and 120, and so on. So what do you think? In the 5th year, the effective rate is 5% or less than 5% or more than 5%? Anyone?
5%.
5%? Anyone else? How many people think it's more than 5%? How many people think less than 5%? So you can see even for the 3rd year, 110 becomes 115. So only $5 increase when we have $110 a year before. So that means the interest is less than 5% of $110, right? So effective rate is actually less than 5%. So you can see that, okay, so I sub 5. What is I sub 5? So A of 5 minus A of 4 divided by A of 4. Sorry. So A of 4 is the 120, right? So 1 plus 0.05 times 4. Then the numerator is 1 plus 0.05 times 5 minus 1 plus 0.05 times 4, or just the 0.05. So this is, okay, so
4.34%.
Yeah, 0.0416, right? Percent, yep. So this becomes actually the the 0.0416, so 4.16%. So it's less than 5%. So simple interest rate is not good if you invest in the bank account. Compounded interest, maybe compound interest of I. So this is the A of t is equal to 1 plus I to the power t. So exponential function. So how about the effective rate of interest for 5th year? It's 5% or less than 5% or more than 5%?
5%.
Yeah, so this is 5%. So this is always 5%. Effective interest rate of interest is I for all t. If I is 5% or 0.05, then A of 5 is 1.05 to the 5th power. So this, and the I5 is A5 minus A4 over A4. So you can see that the 1 plus I 5 minus 1 plus I to the 4th power divided by 1 plus I 4th power. So that this becomes actually 1 plus I minus 1. So this becomes I, right? We at first divide both denominator and numerator by 1 plus I to the 4th power. You can see that this and this is 1, then this becomes I. So a compound interest works in this way. Okay, oh, sorry, that's 11, the 16. So we stop here, and you can solve the first 3 quizzes, the Q1, 10.1, and the 10.2, and the 10.3. Actually, I assigned 4 quizzes, but I didn't finish the next 2 slides. So do these 3 quizzes by the Wednesday night. Okay, so if you don't have questions, it's the end of the lecture, and yeah, see you on Wednesday at 10 a.m. again.
Later.
Okay, thank you. See you later.
Thank you, Professor.
Sure. Have a nice day.